we will continue power. Power is nothing but rate of work done by the object. Rate of work done by the object. Power symbol is capital P. Work symbol is W. Rate of work means it is changing with respect to time. So W by T. This is the formula for power. The unit for power is watt. Capital W, or it is joules per second or kilowatt. So this watt is the SI unit of power. What is the dimension of power? Dimension of power is equal to dimension of work divided by dimension of time. What is the dimension of work? M L square T to the power minus 2. This is the dimension of work. Already dimensional analysis you studied in the second lesson physics. Divided by dimension of time is T. So if T comes to the numerator, it will become M L square T to the power minus 3. So this is the dimension of power. Commercial unit of energy is kilowatt hour. This is the commercial unit of energy. How you can convert this commercial unit into SI unit? 1 kilowatt hour is equal to, kilo means what? 1000. So 1 kilowatt means it will be 1000 watt. Yes or no? 1000 watt into 1 hour. How many seconds are there in 1 hour? 3600 seconds are there in 1 hour. So 1000 I can write it as 10 power 3. Instead of watt I can write joules per seconds into 3600 I can write it as 3.6 into 1000 seconds. Yes or no? Yes. So 10 power 3 joules per second into 3.6 into 1000 I can write it as 10 power 3 seconds. Second and second inverse will get cancelled. So I will get 3.6 into 10 power 3 I will get 10 power 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. So this is how you will convert the commercial unit into SI unit for energy. Okay. So there is another unit for power. Which is called horsepower. Have you heard of the word horsepower? Another unit for power is horsepower. One horsepower is equal to 746 watt. 1 horsepower is equal to 746 watt. So this, what is the unit of power, formula for power? Power is equal to W divided by T. For small amount of power, how we will write? Small amount of power means dP is equal to dW by dt. What is the formula for work done? Work done is equal to force into displacement. So substitute that here, what you will get? D into F into S divided by dt. Take this F outside, you will get F into ds divided by dt. ds divided by dt. Change in displacement with respect to time is called as velocity. Okay, so I can write it as F into v. So dp is equal to F into v. So this is another formula for power. Last topic in this lesson is collision. Collision means what? Two objects are hitting each other. Okay, so one object is here, another object is here. They both are hitting each other. When they collide, what will happen? This object will exert one force on this object, and this object will exert a force on this object. So collision means what? When two objects are meeting, they will exert the force on each other for a short interval of time. That is called as collision. So collision means collision of two bodies means they are against one another each exerting the force on other for short interval of time. There are two types of collision. One is elastic collision and the other one is inelastic collision. So the first one is elastic collision. Collision means what? Two objects collide with each other. They will exert a force on each other for a small interval of time. That is called collision. Two types of collisions are there. What are they? Elastic collision and inelastic collision. Elastic collision means when the object is moving, they need one energy. What energy they need when the object is moving? When the object is moving, they need kinetic energy. So elastic collision means after collision also there will not be any change in the kinetic energy. If there is no change in the kinetic energy, then the collision is called as elastic collision. So what is elastic collision? If there is no loss in kinetic energy, the collision is elastic. Collision is elastic. Then what will be inelastic collision? Yes, there will be a loss of kinetic energy. There will be a loss of kinetic energy in inelastic collision. Let us see the characteristics of these two collisions. First, elastic collision characteristics, then inelastic collision characteristic. In elastic collision, the total momentum is conserved. Total momentum is conserved. Total momentum is conserved means in laws of motion lesson you studied. total momentum before collision is equal to total momentum after collision. So conservation of momentum, like that you studied, yes or no? So elastic collision means total momentum before the collision will be equal to total momentum after the collision. Inelastic collision also the same, total momentum is conserved. Total momentum is conserved means what? Total momentum after collision will be equal to total momentum before collision. Next, here there is no loss in kinetic energy. That means what? Kinetic energy before collision is equal to kinetic energy after collision. So we can say here kinetic energy is conserved. But here kinetic energy is not conserved. Kinetic energy will change. Now we will study about the last one-dimensional collision. One-dimensional collision. In one-dimensional collision, we will be studying about both elastic collision and inelastic collision, but it is one dimension. One dimension means both the objects will be moving in the same direction. Okay, so first elastic collision in one dimension. Elastic collision in one dimension. Listen carefully. I am taking two objects. This is object 1. This is object 2. Okay. This object is having mass m1. This object is having mass m2. This object, one dimension means what? They are moving in the same direction. This object also is moving in this direction. This object also is moving in this direction. It is having the velocity u1. This is having the initial velocity u2. So now what is happening? They both are going to collide with each other. Okay, so during collision. This is during collision. Now, after collision, the mass will not change. This is m1 and this is m2. u1 is the velocity before collision and v1 is the velocity after collision for the first object. For the second object, u2 is the velocity before collision and v2 is the velocity after collision. Now, what is law of conservation of momentum? What is law of conservation of momentum? Total momentum before collision is equal to total momentum after collision. So total momentum before collision means you would have studied in laws of motion lesson. PA dash plus PA is equal to, correct? Sorry. PA plus PB is equal to PA dash plus PB dash. Correct? Total momentum before collision is equal to total momentum after collision. Okay. So what is the formula for momentum? P is equal to M into V. I am taking this as object A, this as object B. So momentum is equal to mass into velocity. So for the first object, what is mass into velocity before collision? Mass is m1, velocity is u1 before collision. For the second object, what is the mass into velocity before collision? m2, u2 is equal to, what is mass into velocity after collision for A object? m1 v1 plus m2 v2. Understood? Now take the u1 terms and 1 terms and all together and 2 terms and all together. So what you will get, m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Take m common, m1 if you take it commonly, you will get u1 minus v1 is equal to m2 into v2 minus u2. So this I am taking it as equation number 1 and this I am going to take it as equation number 2. Okay. This equations I have obtained based on conservation of momentum. What is the second characteristics we studied? Kinetic energy is conserved. Kinetic energy before collision is equal to kinetic energy after collision. What is the formula for kinetic? So next we are going to find the expression based on conservation of kinetic energy. Kinetic energy before collision is equal to kinetic energy after collision. So kinetic energy means half mv square. So for the first object it is m1 u1 square. Kinetic energy of the first object before collision plus kinetic energy of the second object before collision is equal to kinetic energy of the first object after collision plus kinetic energy of the second object after collision. Okay, so if I take half commonly outside, all the half will get cancelled. Yes or no? So what I will get? m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. Again you take this and all commonly outside, one term and all you take commonly outside and two terms and all you take commonly this side. So what you will get, m1 u1 square minus m1 v1 square is equal to, what you will get, m2 v2 square minus m2 u2 square. Take m1 commonly outside, u1 square minus v1 square is equal to m2 you take commonly outside, v2 square minus u2 square. Easier ka? Now this is a square minus b square formula. A square minus b square is equal to a plus b into a minus b. So expand it, m1 into a square minus b square will be equal to a plus b into a minus b is equal to m2 into a plus b into a minus b. So this I am going to take as equation number 3. Understood how you got this equation? Now I am going to divide 3 by 2. This equation divided by this equation I am going to do. So what I will get? 3 divided by 2. We are doing the derivation for one dimension for elastic. So one dimension for inelastic is there, 2 dimension for elastic is there, 2 dimension for inelastic also is there. Okay. Each one is a 5 mark question. So divide 3 by 2. What is 3? m1 u1 plus v1 into u1 minus v1 is divided by, what is 2? m1 u1 minus v1 is equal to m2 v2 plus u2 into v2 minus u2 divided by this side what is there, m2 v2 minus u2. So which and all will get cancelled? m1 will get cancelled, this will get cancelled, m2 and this one will get cancelled. So what you will get, u1 plus v1 is equal to v2 plus u2, or u1 minus u2 is equal to v2 minus v1. So this is equation number 4. Okay. So what we have to find out? We have to find out the velocity of the bodies after collision, because beginning we know with what velocity it is moving. Yes or no? We want to find out the velocities of the bodies after collision. So that is velocity of the body 1 after collision we have to find out. Then velocity of the body 2 after collision we have to find out. So what will be v1 from this? We will get minus v1 is equal to u1 minus u2 minus v2. Yes or no? So if you multiply by minus, you will get u2 plus v2 minus u1. Yes or no? Similarly, what I will get v2 here, this I will keep as equation number 5. So v2 what I will get? v2 is equal to u1 minus u2 plus v1, or I can write it as u1 plus v1 minus u2. This I am taking it as equation number 6. So this v2 value 6 I am going to substitute in the first equation. Okay, so what I will get? Substitute 6 in 1. Tell me what I will get. m1 u1 plus m2 u2 is equal to m1 v1 plus m2. Instead of v2 I will be substituting v1 u1 plus v1 minus u2. Yes or no? So multiply it inside, what you will get? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u1 plus m2 v1 minus m2 u2. Okay, so what you will get now here? m1 u1 m1 v1. So here, can you cancel anything?
m2 u2. m2 u2.
How you will cancel this minus? Take all the m1 terms, u1 terms together and u2 terms together. What you will get? m1 u1 terms and all you take together. m2 u1. Any other u1 term is there? No. Then u2 terms you take together. m2 u2. Any other u2 term? Plus m2 u2. Then any other term is there? No. Then v1 terms, let it be this side. m1 v1 plus m2 v1. Right? Now u1 you take commonly outside, what you will get? u1 into m1 plus m2. u2 you take commonly outside, u2 into m2 plus m2, I can get 2 m2 u2. Yes or no? m2 u2 plus m2 u2, I will get 2 m2 u2. is equal to m1 plus m2 into v1. Yes or no? So what is the formula for v1? v1 is equal to m1 plus m2 u1. Bring this to the denominator. 2 m2 u2 divided by m1 plus m2. So this will be the formula for velocity. Here m2 u1, if you bring it this side, it will become minus. So you please change it into minus. Okay. So this is the formula to calculate v1. How did we find out the formula for v1? v2 value we substituted in equation number 1. Yes or no? If you substitute v2 value in equation number 1, we are getting v1's formula. Now you substitute v1 in first formula and you find out the expression for v2. Will you do? Do now. So v1 value you substitute in the first formula. Substitute 5 in 1. What you will get? m1 u1 plus m2 u2 is equal to m1. Instead of v1, what I should substitute? u2 plus v2 minus u1 plus m2 v2. So multiply inside m1 u1 plus m2 u2 is equal to m1 u2 plus m1 v2 minus m1 u1 plus m2 v2. We need v2, so v2 terms and all keep it this side, u1 and u2 terms and all you bring it this side. So I will get m1 u1 plus any u1 term. This u1 term, if it comes this side, it will become m1 u1 plus m2 u2 plus m1 u2 is equal to m1 u2. If it comes this side, it will become minus m1 u2 is equal to m1 v2 plus m2 v2. u1 u2 v2, take it commonly outside. So what you will get? So here you will get m1 u1 plus m1 u1, you will get 2 m1 u1 plus, you take u2 commonly outside, what you will get? u2 into m2 minus m1 is equal to v2 you commonly take outside, m1 plus m2 into v2. We need only v2, so bring this down this side, you will get v2 is equal to 2 m1 u1 plus u2 into m2 minus m1 divided by m1 plus m2. So this is the formula to calculate the velocity of the next object after collision. So these are the two formulas to calculate the velocity after the objects. Okay. Now some special cases are there. Then keep this as equation 7 and equation 8. Special cases. First case, if m1 is equal to m2 is equal to m. If m1 is equal to m2 is equal to m. So what will happen to this equation, v1 and v2 equation? What will happen to v1? This will be equal. Yes or no? So what will happen? This will become 0. So here you will get 2m u2. m1 plus m2 both are m. So m plus m you will get 2m. Yes or no? So v1 will be equal to u2 if both the masses are equal. And what about v2? V2 what will happen? Here you will get 2m u1 plus this will become 0, this will become 2m. So divided by 2m, 2m will get cancelled. So you will get V2 is equal to u1 if both the masses are equal. Next, second case. If m1 is equal to m2 is equal to m and u2 is equal to 0. What does this mean? U2 is equal to 0 means both the objects are having same mass, but this object is not moving. It is not having any velocity. Only this object is moving and it is coming and hitting. Okay, if that is the case, what will happen to these two equations? Tell me, V1, m1 minus m1, it will become 0. Yes, u2 is 0. 0 divided by anything, it is 0. What will happen to V2? u1 is there, this is m. So you will get 2m u1. This will become 0. This will become 2m. So you will get V2 is equal to u1. Understood? Clear? Now, case 3. If m1 is very much lesser than m2 and u2 is equal to 0. That means what? m1 is a very small object, m2 is a very big object. Okay, if it is a very small object and this is not at all moving, this is having velocity 0. If m1 is very much smaller than m2, we can neglect m1. Okay, so what will happen here? If you neglect m1, what will happen? You will get V1 is equal to minus m2 u1 plus here it will become 0, here it will become divided by m2. So you will get V1 is equal to minus u1. Okay. So V1 is equal to minus u1 means this object will hit and then it will go in the reverse direction. That is the mean. Okay. And what will happen to this term V2? Here this will become 2m1 u1. Here this will become 0. Here this will become divided by m2. This will become u2 value. Okay, so these are the special cases. So with this we are completing elastic collision in one dimension. Next we have to study inelastic collision in one dimension. Next one, inelastic collision in one dimension. So elastic collision in one dimension, the derivation was very big. Yes or no? Inelastic collision in one dimension, the derivation is bigger than that. Okay, but to make it short, the bigger derivation you will study in your college if you take physics as your BSc physics on the Madri. If you take, you will study. Okay, so here how we are going to study is in your 12th standard. They have given a short version of the derivation. What they are considering is, they are considering two objects. Okay, this object is having mass m1, this object is having mass m2. This object is moving with the velocity u1. This object is at rest. That means it is not having u2. u2 is equal to 0. Now, these two objects are colliding. m1, m2, they are colliding, and after collision, both m1 and m2, they are moving together with the same velocity v. There is no v1, v2. Both are moving with the same velocity v. If you take it as u1, u2, v1, v2, the derivation will go on very big. Okay, but here in order to avoid the big derivation for your 12th standard syllabus, they have taken u2 is equal to 0, and instead of v1 v2 they have taken generally as v. So now what is law of conservation of momentum? Law of conservation of momentum in previous derivation, equation number 1, what is that? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Yes or no? Here there is no u2. u2 is 0. So what will happen to this equation? m1 u1, this term will become 0 because u2 is equal to 0, and there is no v1 v2, there is only v. So it will become m1v plus m2v. So we will get m1 u1 is equal to m1 plus m2 into v. So this is the first equation. So we need not find out the final velocity and initial velocity and all. There is only one final velocity. There is no v1 v2 here. If you take u2 v1 v2, you can do that. If you want, you do, no problem. Okay. So here there is only one velocity, that is m1 u1 divided by m1 plus m2. So this is conservation of momentum. Okay, next what did we take? Conservation of energy. In elastic collision, kinetic energy is conserved. Kinetic energy is conserved means total kinetic energy before collision is equal to total kinetic energy after collision. In inelastic collision, it is not conserved. Okay, so you will have two kinetic energy. Ki is the initial kinetic energy and Kf is the final kinetic energy. Okay, so change in kinetic energy is equal to Ki minus Kf. In some books they would have done Kf minus Ki. That also you can do. You can do final minus initial or initial minus final. If you do initial minus final, the answer you will get in positive value. That you have to mention at the last. It is a positive quantity like that. If you can do final minus initial also. If you do final minus initial, the answer you will get in negative value. You have to write that it is a negative value like that. Okay. But either way you can do. Okay. So what is Ki? Half m1 u1 square plus half m2 u2 square. Yes or no? But u2 is 0. So what will happen to this term? This term will not come because u2 is 0. Okay. Minus final kinetic energy. Final kinetic energy means half m1 v square plus half m2 v square. So you take half v square commonly outside, what you will get? Half m1 u1 square minus half m1, am I doing it right? m1 plus m2 into v square. Like this I will get. Yes or no? Half I am taking commonly outside, m1 plus m2, v square I am taking commonly outside. Now this v you substitute here. Substitute this v term here. What you will get? Half m1 u1 square minus half m1 plus m2 v square. V square means this will become m1 u1 the whole square divided by this will become m1 plus m2 the whole square because it is v square. So 1 m1 plus m2 and 1 m1 plus m2 will get cancelled. So you will get half m1 u1 square minus half m1 square u1 square, correcta, divided by, you will get m1 plus m2, like this you will get. Okay, so here what I can take commonly outside, half m1 u1 square. Can I take commonly outside? Half m1 u1 square I can take commonly outside. So if I take half m1 u1 square into 1 minus remaining, what is that? 1 m1 we have, half we have taken outside, m1 1 we have taken outside, u1 square we have taken outside, remaining 1 m1 will be there, divided by m1 plus m2. So this is the kinetic energy of m1 u1 square into 1 minus m1 divided by m1 plus m2. If you take the ratio of, so this will be a positive quantity. It is a positive quantity. If you do final minus initial, here you will get minus sign in the beginning. Okay, you can do final minus initial, you will get minus sign in the beginning. There you should write it is a negative quantity. Okay, and one more expression, if you divide k final divided by k initial, you will get m1 divided by m1 plus m2. We need not derive this, only the expression you can do. If you want, you can try it. Okay, derivation kf divided by ki. Understood? If m2 is very much greater than m1, you will get kf by ki is equal to, this m1 is very less, means you can take it approximately equal to 0. So you will get kf by ki is equal to 0. That means final kinetic energy will be 0. This is the special case. So this is total, sorry, inelastic collision in one dimension. Okay, so we have cut short this derivation by taking u2 is equal to 0 and v1 and v2 as commonly v. Okay, but the full derivation it will be in your college. Okay, so with this lesson is getting over. Tomorrow we will start new lesson in chemistry, organic.